everyone, Insomnia from UnrealTech.net again, a division of BlenderTek.com. Today let's change paces. I don't want you all to get bored of blueprinting, so let's create a real-time mini-map. We'll be able to show team-colored dots for players on a screen for enemies and our teams and different teams once we get to doing team deathmatch and such. We'll make it expandable to full screen or almost full screen anyways. We'll be able to mark things like bases or flag locations, and eventually we'll set up things possibly like fog of war and only being able to see enemies within a certain distance, and maybe adding player names and such in the expanded mode. So open your project and remember, create your way. So let's start off under our blueprints folder. Let's create a new folder called minimap. We'll go minimap. Let's call it minimap blueprint. So I'm gonna set that to green since we're gonna be working on that today. And let's start with the core component of this. So a new blueprint class, and it's gonna be a scene capture 2D. So this is gonna allow us to capture an area and use it on a material. So select scene capture 2D as your class. And let's call this BP mini map capture 2D camera, and let's save that. We're also going to need a widget to display it, so let's go under we'll keep it all in this folder for now. So let's create a new user interface widget. This is going to be widget underscore minimap. And we're also going to need a blueprint function library. So let's create a blueprint function library, and we'll go BPM, or that's macro, BPL, we'll go minimap. So let's save those for now. Those are our most important things for now. And yeah, so let's save everything. Let's start, like I said, with our capture 2D camera. That's going to be the most important part of the whole setup. So what we're going to want to do in the construction script is we're going to want to get all actors of class, and that will be of type landscape. So this is going to find the actual landscape if it exists. We don't have one here, but if we did, we would see the landscape exactly. And obviously your levels will most likely have a landscape, so we'll want to be able to see that. But we'll only see it if it's there. And we're going to do that by getting the length. So how many landscape actors are there? And we're also going to want to do an array get. We're going to want to get the first one if it exists. And we're going to want to check the length is greater than 0. So, and then that'll go into a select object. And A is going to be the first one, B is going to be nothing. So Control Shift S. Let's just straighten these out. Oops. So what we're doing here is get landscape actor if it exists, and we're going to want to take the return value and we're going to want to do a peer cast to landscape, because we're going to want to get world, where are you? size. Right there. Nope, that's not it. That's actually a custom function I created. So let's go into our function library here, and let's create one called get world size. So this is going to tell us the entire size of the landscape in terms of 2D vectors. So we're going to get the center, we're going to get the bottom left, the top right, and half of it. So what we're going to want is we're going to want an input. So we're going to want landscape in, and this is going to be of type landscape reference. And then we're going to need some vector 2Ds. So we're going to want the center. So I'm going to go CTR, and that'll be a vector 2D. So a vector 2D is just X and Y. Since we're working with 2D images and not 3D, a 3D minimap would be pretty crazy. I don't know why you'd need it. So we only need 4 points. So we're gonna want top right. We're gonna want bottom left, and we're also gonna want halved size. So the size of it in half, basically. So what we're gonna do here is we're gonna use something I like to use but I don't do a lot, and that is get actor bounds. So this gets the bounding box of an actor. So basically if it was the shape of this node, it would get a square around it. If it was these two nodes, it would get my marquee selection there. That would be the bounds. And we also want to create another one called get size of world, and this is going to be called in there. It's pure, and this is going to be very similar. It's going to have only 2 vector 2D outputs though. It's going to have bottom left and top right. I don't know why I went bottom left, top right, and it's going to have a landscape reference input again. So landscape in. And we'll do that one next, but we'll start here. We just needed that function first of all. So what we want to do is we want to call get size of world, and it creates this world context node. There's no way to get rid of it. You're just kind of stuck with it. So what we want to do is we want to we're going to need to create another function which is going to be useful called get middle vector. So you have get forward vector, get right vector. You don't have a get middle vector, unfortunately, as a default Blueprint function, however. So we have to create it. So this is going to be completely vector 2Ds. So we're going to have vector 1 in. We'll just go vector 1. We're going to have vector 2. And then we're going to return the middle. Or we could go center V2. So let's do this one because it's pretty easy. So what we want to do is we want to break each vector 2D into its X and Y components. And we're going to need another simple function for this called get middle float. So it's going to take a float, 2 floats, and divide them by 2. So it's just a helper function because we're going to use it over and over. This one's going to be pure as well. It's going to have 2 inputs, which are going to be floats, and an output float. So this is going to be the center or the middle. or the average, I guess you could call it. We'll just stick with center since we're working with vectors. This is going to be float 1 and float 2. And so all we do here is, and make sure it's pure, we just take these and we add them. And then we divide by 2. So it takes 2 floats and gets the average basically. So what we need to do here is we need to do that on all of these. So we want to do vector 1 and vector 2. We want to do it on both of them. So we want to get middle float on x and x. And then we want to take the center and make a vector 2D out of it. So make vector 2D. And then we want to do the same for the y. And then we return that. So what we're doing is we're taking 2 vector 2Ds, whoops, and getting the average, so the middle, aka center, of x and y, and then returning it as a single vector 2D. And get middle vector here, this should be pure as well. Let's compile and save. So get size of world, we can continue working on that. So, or I'm sorry, get world size, I mean. So now we can do bottom left, we want to get middle vector now that we've got that completed. We get all these world context when you're working with blueprint functions. You could do these in a macro library too, possibly, but you want to be able to call them as functions when they're pure too, so most of them you can't. In fact, this one's pure too, I totally forgot. So we're going to return the center vector is going to be the center. The bottom left and top right are going to be exactly as you see there. So bottom left, top right. I guess I should have switched those, oh well. And then to get the center, all we do is we take the box extent and we just convert to a vector 2D. So 2 vector 2D. And so that'll take, this will take the x and y and turn it to a vector 2D, and it'll give us the size halved. So just like so, we can compile. And so we can go back here now to our capture 2D camera. So as landscape, we want to get world size, not get size world, get world size, and we want to take the center and break the vector, as well as the half size. We want to break that vector as well, and because it can be negative if you're working with a negative vector, we want to take the x and we want to get the absolute value, so make sure it's positive. And then we are going to take our capture component 2D. So this is the actual scene capture component. We want to get our field of view angle. So how much can we see? And we'll set all that up too. And we want to go into a math expression. So I'm going to, I'm going to go off field of view angle. I'm going to go math expression, math expression. Where are you? Add math expression. So it's going to be half size times t and 90 minus field of view divided by 2, I think 4 brackets. Yeah, there we go. So half size comes from there, field of view down there, and then we take the return value, we multiply it by 1.5. So float by float times 1.5. That can be adjusted to get a different height as well. And then we're setting the actor location for our scene capture component. So we're coming all the way over here and we are set actor location. So where is our capture component going to actually capture from? So we're going to make a vector in new location, and let's bring it over a little more. This is the Z, so that's, like I said, the height. And then our X and Y obviously just comes from the center, X and Y here. So X and Y. And this is in the construction script because it needs to be constantly updated. These are going to be constantly changing. So now we need to go to our event graph and we need to create a custom event called update capture. And so when this is called, then we're going to call it at the end of our construction script, so we might as well do that now. So just call update capture. So what that event is going to do is we're going to take our capture component 2D. We're going to set relative position, set relative location, sorry. So first we're going to reset it like so. And then we'll reroute. And then we're going to do it again. And the second time, we're just going to go 1 unit down in the Z. So basically, the down vector, 1 unit. And so that's all we do. So compile and save. And let's set up our capture component 2D. So post-process blend weight is 0. We don't want any post-processing on it. You could add effects if you want, though, and we will be doing that later to get some advanced stuff like fog of war and just other effects during certain times. Our field of view, we want it to be extremely low, something like 15 degrees. Scene color HDR, capture every frame, no. What else? And then our textured target we need to set up. So let's go back to our minimap folder in Blueprints and right click and go to materials and textures and choose a render target. And so this will be our render target 2D underscore minimap, and we'll put T before it. Render target 2D minimap. So we'll save that. You can open it up, and we want it to be, you can choose the resolution you want. I'm gonna go 1024 by 1024, so we won't exceed that size. We can, but we probably won't, and if we want, we can make it bigger. So now we can go in here and we can select that render target, and that is totally set up. The rest have no settings, so they are fine, and we don't need any replication because this is all client side. So let's compile and save. That is our capture 2D camera component done. As you can see, it's capturing nothing, just green, but at least something's working. So So we're gonna need some more functions for use in the widgets, and I want to organize these a bit first. Get world size. I'm gonna put this in the category of maths. Get middle vector and get middle float are also in there. Oh, you can't drag and drop them in this, eh? So I'll put that in maths. And the rest are just default functions. So let's continue with the math functions. So we got get middle float, get middle vector, get world size. We're gonna need a vector 2D divided by vector 2D. Vector 2D divided by float is all you can do. You can't divide by a vector 2D. Now you could do it manually by dividing by float, but this just makes our job a whole lot easier. So vector 2D divided by vector 2D. So this is gonna have two vector 2D inputs and a vector 2D output. So out vector 2D. So one vector 2D, two vector 2D, and this one's pretty simple too. This is also a pure function. That's why I'm not using a macro library. So we're going to make a vector 2D and we're going to break both of these. And then we're going to just divide their x's and their y's and plug them in. So divide float by float, x by x goes into x, and y by y goes into y. A lot of these will come in handy when we make things like night vision modifiers and stuff too. We're also gonna want so that one goes into maths. We're gonna want a swap vector 2D. This one has two vector in one in, one out. It's also pure. It's also a math function. Again, a very similar one. This one just swaps them. So vector 2D in, vector 2D out. So all we do is we break and make and then just swap x for y. So we break, we make, y goes into x, y goes into x, just like that. So that's kind of self-explanatory what it does. Let's compile and save while we're here. We're also going to want to be able to round them to the nearest value. So let's do a round vector 2D. And this one, again, will just have an input and output. So v in, v out. So what we're going to do here, and this one's also pure, we're going to make a vector 2D and break again. And what we're going to do is round. So we round them to the nearest integer value, and then we convert them back to floats. So that gives us whole numbers to work with, obviously. And this one is a math function. We're going to need a vector 2D. As you can see, if I type in vector 2D, there really is no vector 2D stuff you can do except for plus and minus. So we need all the other ones. And that's just because you can do a float minus a float and a float plus a float, but I guess I just haven't done the other ones yet, or thought that it's useful, but it does come in useful when you're working with 2D stuff. And I'm sure as they work on their 2D part of the engine, they'll get more of that. So yeah, we'll need, I'm just gonna duplicate this so it stays in the proper category and such. We're gonna need vector, let's go vector 2D times v2d. So this will have 2, so vn2, and so we're gonna break, oops, I totally did the wrong one, the wrong one there. So we're gonna break both of these, and then we're gonna do a final make, and what we're gonna do is multiply the x's and y's and then put them into their respective. So x by x, y by y, and then plug them into their respective inputs. Compile and save. So I'm gonna duplicate this again. We're gonna do a vector 2D is less than vector 2D. We're gonna want to check that. So in this one, these are all pure function. This is pretty easy. We just take like so, and we check if the x and y's are less than, and we do an OR boolean. So less than x or less than y. If one is less, then obviously we have one that's less. So we just do an OR boolean. I guess it doesn't matter which way they go, but I'm a neat freak. And then this one's gonna be a boolean out. So I'm gonna go vn1. So 1 less than 2. So b 1 less than 2. Why not? All right, and we're gonna want to do a another one, which is gonna be a vector 2D map range. So just like mapping a float range, except for with vector 2Ds. So I guess I should have done a different one. This one returns a vector 2D again. So this is v out. We have 1 and 2, and then we also have a float in. So we need to so range in. So what we do here is we take our range in and we map range unclamped, and we're gonna need 2 of those. So copy and paste, and we're gonna take the x of the first one and it goes into A, and the y goes into the A of the bottom one, and inversely the x up here goes into B and the y goes into B, and the range in goes to both of the values. Now we go between 0 and 1 and 0 and 1, and then we make a vector 2D. I guess I can just, yeah, whatever, and return it. And then lastly, we just want the absolute. So we want to take a vector 2D and make sure it's positive. So we'll duplicate this, and this vector 2D ABS. So in this one, we just simply break 1, so we can get rid of the float, and we can get rid of 1. In, v out, we'll go v in. So all we do is we just go ABS on both of the floats and then plug them back in. So that way if we have a negative, we get a positive no matter what. So compile, save. Then we need a few functions, about 5. We've already got 1 done, just to help us. So let's see, we're going to add a new function called get follow location. So you'll call this function when you go into a vehicle, when you're spawned, etc., and it just says which actor is the minimap gonna center on. So we're gonna have an input which is gonna be owning player or owning pawn, because it could be a vehicle, and this will be of type pawn reference, and then an output vector which will be location. So all we do is we get the actor location. And then return that. So which pawn to center on. And this one's peer. Let's see, get size world is peer. Yeah, perfect. We also want to get the rotation. So let's duplicate that and get follow. Let's just do rot. Why not? And so this one outputs a rotation, or a rotator rather, sorry. So what we want to do is we want to take the owning pawn. We want to cast to base character. And then we want to get view. We created we'll get camera view third person and get camera view first person, and we're also going to want to get B in third person. We're going to want to go into a branch and check if we're in third person. If true, we get the camera view of the third person camera and return, and then we take the desired view. No, that's not going to work. Return like so. If false, we want to get the camera view of the first person and then return and break the minimal view info and the rotation. That should work. If not, if rotation is broke, this is the function to look at. But yeah, this is the rotation the minimap will follow. I don't want to do it straight to our character without and just one camera, because obviously we're going to change that. We have get size of world. We're going to need get follow position on map. So one new function, get follow position on minimap. This is peer, so this is where on the map is it going to rotate and move around, and we want the center, but you can adjust that if you want. This is going to be peer, and it's just going to output a vector 2D. So this is going to be we'll go position vector 2D, and so we'll just give it a default of 0.5, 0.5. So that works just like a widget's what do you call it, pivot. And then lastly, we want an on click. Yeah, on click. We'll probably use that for a lot of things. So this one isn't peer. We're gonna have 3 inputs though. We're gonna have a BP player controller reference. This is gonna be the owning PC, and then we're gonna have 2 vectors. whoops, not text, vector. We're gonna have world location and traced world location. And what we want to do here is we want to spawn emitter at location, and the world context object is owning player controller. World location is location, or traced world location is location. I'll destroy yes. Emitter template can be anything. We'll do explosion. So what happens when player clicks the minimap? So we'll obviously be adjusting that, but at least we'll get something visual. So we can save that. That's all the functions we will need. So now we can work on the actual minimap widget. So let's open that up. And so all we need is our canvas panel, and then we're gonna want to add the actual map that we see. So let's right click, user interface, widget blueprint. This is going to be widget underscore map. We'll go map render target. And so let's open that one. And this will have a canvas pan. Well, first let's set the size. 2096 by 2096. Custom. And we want to just put an image down into our canvas panel, and that image is going to be, as you might have guessed, our render target. So under brush, we want render texture underscore, where are you? I need to create a material, I mean. So let's do that first of all. So we'll do a map. We'll create a material. This is going to be material underscore map render. And if we click anywhere blank, this is just going to be a user interface material. So very simple. It'll be opaque, so we can leave that just like that. So what we want to do is we want to get the texture coordinates, and then we want to do a custom rotator, and the rotation angle, we want to create a parameter. Where are you? Vector parameter. Sorry, no. Scalar parameter. Where are you? Scalar parameter. So we'll go between a default value will be 0.1. Minimum maximum will be 0 and 0. So infinite. The parameter name will be rotation. And that'll go into the rotation angle. Then we'll take the rotated values and we'll go into a texture. And that one is going to be our T render, and then that'll plug into our final color. So save. And we could probably get a, if we threw this in our world, oh, that's the, I threw the, didn't mean to do that. If we threw this in here, not that's the material. If we threw this in here, we could actually get a preview of it almost. Let's see, where is it? It's pointing at nothing. And it doesn't want to move. We'll play with that later. So we got that material set up. Yeah, you can see some things starting to happen. So at least we know it's working. So save, close. So now we can set this to material map render. And so this will be updated constantly. And we want this to fill the entire thing. So I want to size X 0, 0, and the anchors to all four corners. Offset 0, 0. So just like so. That should work, I believe. And we want this to be a variable. This is going to be our canvas. We also want this image to be a variable. This is going to be the minimap image render. So let's compile and save. Let's save everything while we're at it. Let's go into the graph. And we're going to need a few things, but let's start with update image. So let's create a function called update image. And what we're going to do is we're going to create a variable called 2D capture or capture 2D camera. And this is of the type capture cam. Right there, our BP minimap capture camera. So we want to take a reference to that and we want to call it update capture. Compile, that one's pretty easy. What else? There's a bunch of other complicated stuff. I'm going to save it for another episode, but we can go into our actual minimap widget. We can take our canvas panel and we can add our, oh, what the heck did I call it now? Widget map render target. That can go into our canvas panel and we can set the anchor to the top left. We can set the size of our mini map, so something like 512 by 512, and we can set our image to be that size, so 512 512. Like so. We want that to be a variable. Yep. We can go into the graph. And we'll create a function on here as well called update image, which will do the same thing. We'll add a variable called capture 2D camera. Whoops, same deal, whatever. Of type BP. Okay. I keep forgetting what I call it. BP minimap capture 2D camera reference. So we'll call that update image, update capture rather, and to update the image. We have that function. What else is easy that I can do really quickly? We can get minimap's rotation, get rot. I'll do, and this will have an output, which will be a rotator. So this will be rot out. This will be peer. And what we'll do is we will get owning player pawn. And then we want to get follow rot. So that uses the cameras, if you remember. So that one's good. We can also do get location, so we can just duplicate this. Get location. So this gets the rotation and location of the owning player pawn. So we want to get follow location, and then we want to output a vector. So lock out. We can set top left position. This one isn't pure. This takes in a geometry structure. Geometry, something few people know about. This will be geometry in. And so what we do is we do a local to absolute. Not many people know how to work with geometry, and we want to also take, we want to create a variable, which is going to be our geometry root, which will be of type geometry. We want to take that and we want to do a local to absolute on that as well. And we want to subtract them. So yeah, vector 2D minus vector 2D. And then we want to create a new variable called minimap top left. And that'll be of type geometry. And so we want to set that to or rather, sorry, that one should be on our other one. So we want to get our, where is it? Our render target. And we want to go to that one and create a variable called minimap top L of type geometry. Compile. Compile since it gave me an error, and then we want to set minimap top left to this. And that should not be geometry, that should be a vector 2D. That was a dumb mistake. Compile. You're just being mean to me now. Compile. Now it should work. There we go. So yeah, it does it like so. Yeah. I guess we can do one more thing. We'll compile and save all this. I'm going to save the heavy functions for later. We are going to create a blueprint class actor. So it'll be BP minimap manager. Let's see if there's anything quick we can throw in there. What we want to do is in our event graph, we want to create a variable called owning player. And that is going to be of type BP player controller. Reference has to be editable and expose on spawn. And so on event begin play, we want to take our owning player and enable input. And this is going to allow us to create the minimap much larger when we press a key. So be like left alt, we could go like say enter and alt. So like alt enter, then we'll do a flip-flop, not a for each loop, flip-flop. And we'll want to take our owning player and get viewport size, and on A we'll want to set we need two variables. We want windowed resolution and full screen resolution. I know I spelled those totally wrong. Vector 2D. Vector 2D. Let's compile. So we want to set our windowed resolution. So that'll be of our mini map. We'll use this. Let's split this, and the X goes in there and the Y goes in there. When we press it the first time, and then we're gonna execute console command, and we'll do that all later. I don't want to get into all the appending and stuff, and we'll use our full screen resolution there. And on B, we'll just do the inverse. We will just execute console command, specific player, owning player. We don't want to expand everyone's minimap. We want windowed resolution. So yeah, we'll complete that next time. So we have all the core components for a minimap, however. So yeah, we can set that up to start actually capturing some stuff at some point. And we'll make a nice little minimap. We'll make some little UI bits so that we can mark things like vehicles and whatever. So yeah, I'm gonna leave that there for now, and we will complete that next time. Or if anyone has something else they want to see, just let me know and I'll rock and roll through it. We'll come up with something. Or if there's something, like I said, if you want to continue on the guns or tanks or vehicles or whatever, let me know. Otherwise, we'll finish this up next time. So thanks again for watching. If you learned something, please like the video, subscribe. We also take donations at paypal.me/BlenderTek. If you disliked this video, please tell us why. So we'll see you next time. Remember, create your way.